Chapter 4, Greatest Common Factor. And I hope you're watching this one because this is the one that's hardest to remember. Number one mistake. So pay attention. So I'm going to skip here. I'm not going to do all the warm-up I did with some of the other videos here. I just want to point out this to you. Most of the time when you factor, and if you watch some of the other videos, they end up looking like that. Two binomials, two sets of parentheses. But when you do the distributed property, you have one term on the outside and multiple terms on the inside. So it does have a little bit different look to it. So if you look at this example right here, it could be the two sets of parentheses deal, or it could be a greatest common factor. And the only way to find out is to try what I'm about to show you. But again, the point being, you put for greatest common factor, you put one term out here in front, and then however many terms was in the problem. So I see two terms in the problem. That means I will put two terms in there. Let me change up, get a different color. Okay, so greatest common factor. What we're saying is, let's start with the numbers. What is the greatest number that goes into both of those guys? So 5 goes into 15, 5 goes into 5. So 5 is the biggest number, or greatest common factor between those. This guy has one B, this guy has two B's. What's the greatest number of B's common? Well, the first one only has one, so it can't have more than one in common. This guy has two C's, this guy has three C's. What's the largest number of C's common to both of them? Well, again, the first one only has C squared, so we can't have any more than that in common. So that's the greatest common factor. And then what we just have to do, excuse me, is kind of do the distributive property in reverse. And we go, well, this guy times what would give me the original problem, and this guy times what would give me the second half of that problem. We'll go back to the 15 here that was in this original problem. 5 times what is 15? I got a 3. Well, if you factored one of the B's away, there wouldn't be any B's left. And if you factored two of the C's away and put them out front, there wouldn't be any C's left. So that's it for that one. But here's the upside of this. You can always check it. If I were to multiply these two out, do you get 15bc squared? The answer is yes. Okay, the second one. So distributive property in reverse. So 5 times what would give me the 5? Well, 1. Okay, now you wouldn't have to write the 1, but that's okay. I have one B out here, but I'm supposed to end up with two B's. So there must be one left over. I have two C's out here, but I had 3 to start with, so there must be one left over. So again, the beauty is you can times the outside guy times the inside guy, like you normally would do the distributive property to see if you're right. And it was a plus in the middle. Okay, and that's it. But that's the key. Before you can worry about this thing, where you get the two parentheses, you have to try greatest common factor first. So always try greatest common factor first. Okay, example number 1. So rather than just cut the two sets of parentheses, which granted is the case more often than not, and that's why I get all cranked up about this whole greatest common factor thing, is because people just flat out forget. So here's what I want to try to do. I want to ask myself, is there a number that goes into all three of those? And the answer is yes. 3 goes into all three. Is there anything else common? Well, this guy has an X, this guy has an X, and this guy has an X. Do they all have Y's? Well, the third one does, the middle one does, but the first one does not. So it has to be common to everything for a GCF. So no, they don't all have Y's, so I don't do a GCF of Y. And that's my greatest common factor, and I'm done with that part. So now we just have to kind of do the distributive property in reverse, and we have to try to figure out 3x times what will give me that first answer. Well, 3 times 3 is going to give me the 9, and there was already an x, so I got that covered. Minus 3 times what will give me 12? 3 times 4 will give me 12. I already have an x, so I don't have to worry about the x. But where did the y go? Well, he doesn't go away, so I need to still have him. But again, check it. If I were to take the 3x times the 4y, do I get 12xy? And the answer is yes. So 3x times what will give me that last one? 3 times 1 will give me the 3. And again, no, you don't have to write the 1. I have 1x. So if I'm going to get an x squared, I need one more. And no y's. So the only way I can end up with that y is to leave him where he was. But again, distribute that back out, and you know if you're right or not. So that's the beauty of these. Okay, number 2. Well, I hope it's pretty obvious that 2 goes into all 3 of those. Now, do they all have m's? The answer is no. Do they all have n's? The answer is no. So it is possible to have a GCF that's just a number and not a letter. Well, 2 times what gives you 8? And I never did mess with the m. 2 times what would give you 6? And I never did mess with the n. And 2 times what would give you 10? And that one didn't have any variables. And that's it. So I hope you're thinking this isn't so bad. But again, the key is to remember it, because most people want to automatically jump to the 2 parenthesis answer, which is not always the case. All right, what number goes into all of these? 7 goes into all of these. Is there anything else common to all of them? They all have r's, but that last one doesn't have more than 1. So you can't have more than 1 in common. Now, here's the question. Do you want to make that positive 7r for your GCF, or do you want to make it negative? Well, in all honesty, either one would be correct, but to make it easier, I'm going to ask you this question. What else do these guys literally all have in common? And they all have a negative sign. So I might as well make my GCF negative. Well, if that guy's going to be negative, what's going to do all the answers? Well, hopefully you can figure that out, but let's go ahead and do it. So negative 7 times what would be 14? Positive 2. If I had 1r, how many more r's do I need to get that r cubed? I would need 2 more. So a negative times a positive would give me the 21. And 7 times 3. Again, if I have 1r, how many more r's do I need to come up with that r squared? 1 more. And now I can't, you might think to yourself, well, hey, wait a minute, I took that negative 7r and I put him out front. He's gone. There's nothing left. But remember, factoring is something times something. So I got to have something there on the end. So negative 7 times what will give you negative 7? And the answer would be 1. That was a terrible 1. There we go. Okay. The r, well, I had 1 r out here, so I don't need any more to complete the process. So there you go. But here's why that ended up being a good idea, putting this negative sign out in front. So what are the signs of everything that's left inside the parentheses? They're all positive. So the less negatives, the better. So you could have done positive 7r out here, but then all these guys would have ended up being negative on the inside. Not as good. All right, but again, ultimately, if you want to check these, all you have to do is distribute them out, and you will know if you're right or not. Does it match the original answer? And it does. All right, so coming up here, well, if you watch the video that has multi-step factoring, the GCF thing is always going to be number 1. So in other words, you always try him first, no matter what. All right, guys, thanks for watching.